I'm going to go ahead and try one. So this is 1.10.16. Now to find it again. So this one tells us it's found that 28% of orders received by a company are from first-time customers. So the probability of a first time equals 0.28.
Professor?
Yes?
We just have a quick question about the kind of format of the test.
You start with f of x equals 2x, and they say find the PDF and the expected value for y in all the following cases. So like for A, y equals x cubed. Okay, and we want to find the PDF and the expected value of y. Now, what will you have to do on the exam? You will not actually have to find the PDF of it because it is very long and complicated. What you actually have to do is you find the CDF of x, then you switch to the CDF of y using that complicated trick that I expect you guys won't really truly understand the first time you learn it in this class. And then you do the derivative to the PDF of y. Okay, so we integrate to get the CDF of x, switch to the CDF of y, and then take the derivative to get back to the PDF of y. That's way too complicated for me to ask you on the exam. Okay, but you can find the expected value of y very easily. What would you have to do? Oh, and this is for x between 0 and 1. Okay. So expected value of y is just equal to expected value of x cubed. And so if you want to find the expected value of anything, we just integrate what you want to find the expected value of times the CDF. That you should be able to do, and I would expect you to do that on the exam. And what would my bounds be? From 0 to 1. So we'll go from 0 to 1 of x cubed times 2x dx, and whatever you get there. So I will tell you for this, okay, we did the binomial distribution. You should know everything right there. You don't need to know the rest for the exam. Okay. At this point, I figure if you've kind of seen how to use a bunch of different distributions, and you kind of understand, okay, I plug things into the PMF, or this is how I get expected value, I'm not so worried that you know all of these different distributions. So that's why Chapter 4 is not on there, and the geometric, negative, and Poisson aren't on there. So all you have to do is binomial. If you're doing the review, and you come across a problem that says use geometric or negative binomial of 10 cards, chosen without replacement, and we want, what is the probability that we get 2 aces, 2 kings, 3 queens, and 3 jacks. There's usually a few different ways you can do all of your probability questions. I saw this one and I thought about combinations. Just the fact that I'm getting like 2 aces and 2 kings and 3 queens and 3 jacks. So I started thinking about combinations and I said, okay, let's find this probability. I would have to get 2 aces. Okay. So for my 2 aces, I would need, there's 4 aces total. I need to choose 2 of them. So I would do like 4 choose 2. Okay. And for the kings, there are 4 kings and I need to choose 2 of them. For the queens, there are 4 queens and I need to choose 3 of them. And for the jacks, there are 4 jacks and I need to choose 3 of them. So I'm thinking there's a lot of different combinations going on here. So if I want the final probability, I'd start by saying, what's the number of ways to get what I want? over the total possibilities. So that's always kind of our general formula for probability. How many ways can I get what I want over the total possibilities? Okay. So I need to get 4 aces, or 2 aces. And there's 4 aces total, and I need to choose 2 of them. I don't really care which 2 I choose, or what order, I just need 2 of them. And then I would multiply that, because I also need to get 2 kings, and there's 4 of them available. And then I need 3 queens, and there were 3 of them, or 4 of them. And there were 4 jacks, and I need 3 of them. Now again, I'm doing combinations because it's all without replacement. Okay, I don't put them back. I don't have another chance to draw again. And I really don't care about the order. Okay, so the order does not matter here. And which kind of includes you in also as well to the combinations. And then what were your total number of possibilities? There are 52 cards, and I need to choose 10 of them. And this gives me 3.64 times 10 to the negative 8. So that's quite a small probability, but it was a very specific thing they wanted. So I know that's from section 1.7. And finding probabilities with combinations might kind of be that harder one. So that's why we reviewed that. So let's do a different probability one. So this is 1.10.16. So they tell us that 28% of orders received by a company are from first-time customers. So the probability is their first time equals 0.28. The other 72% come from return customers. So the probability of a return customer is 0.72. In addition, 75% of the orders from first-time customers are dispatched within 1 day. So the probability is saying from the first-time customers are dispatched within 1 day. So they're saying if you know that they're first people, the probability that they're out in 1 day is 0.75. Okay. And overall, 30% of the company's orders are from repeat customers whose orders are not dispatched within 1 day. And this one, the wording might seem slightly different, but it's overall 30% are from repeat customers and not dispatched within 1 day. So the probability of the return and not 1 day, so let's say 2+ days equals 0.3. Okay, so this is everything that they give you. And it probably seems like, what am I going to do with this? So this is where you kind of start remembering your rules. We'll start drawing out a tree. Okay, so here's my first customer or return customer. And then if it's a first customer, you can go out, the order can go out in 1 day or 2+ days. If it's a return customer, it can still go out in 1 day or 2+ days. So the probability that was first, we said that was 0.28. The probability for the return was 0.72. The probability that goes out on the first day, if you know it's the first time customer, is 0.75. And if this is 0.75, what does this branch have to be? 0.25, right? Each set of branches always has to add up to 1. Okay, but what about this 0.3? That's kind of what makes this problem difficult. Notice that was for the probability of the intersection. Where do the intersections go on these tree diagrams? The intersections kind of always go over here to the side where you multiply. So we can find the probability of first and 1 day by multiplying along those branches. So 0.28 times 0.75 gives me 0.21. And the probability of a first-time customer and 2+ days equals 0.28 times 0.25 or 0.07. But I haven't figured out what these branches are yet. But they did tell me that the probability of the return and 2 plus days equals 0.3. So if you know that this is 0.3, this is 0.72, can you figure out what this branch should be right here? If we were always multiplying to get to the probability of these intersections, how do we get back to this branch? We would just divide, right? So 0.3 divided by 0.72 is this 0.4166. Okay, so we could get this by 0.72 times 0.4166 equals 0.3. Now I think that's kind of more difficult. This is one of the things where I say the book is more difficult because you probably haven't had to work backwards to find those missing branches yet. But with that in mind, I do want you to be able to know how to do the rest of this problem. I probably wouldn't make you have to find that backwards branch, but I want you to be able to do everything else. Okay, if this is 0.4166, then what is this branch? They always have to add up to 1. So 1 minus 0.4166 gives me 0.5834. So the probability that it's a return and goes out in 1 day equals 0.5834. Oh, sorry. We have to multiply the branches, so 0.72 times 0.5834 gives me 0.42. Now when you're done, add up all of these intersection probabilities and make sure they add up to 1. That's how you double check your work. Now that we did all of the tree diagram and we found everything on the tree diagram, the question asks us, if the order goes out in 1 day, what's the probability it was for a first-time customer? So it's asking me, what's the probability? We know it's 1 day. What's the probability it's for a first time? Okay. How do you find conditional probabilities? Do you remember those formulas? You have to do the probability of the intersection divided by the probability of what's given, the thing that comes second, so 1 day. Now I can just look up here, probability of first and 1 day, we found that is 0.21. How are you going to find though the probability of 1 day? They never gave you that anywhere. Okay. That's why we like tree diagrams. What you do is you just find all of the intersections that have a 1 day. So this one has a 1 day, and this one has a 1 day, and you add them all up. So 0.21 plus 0.42, which gives me 0.333. So if you're kind of getting a lot of probabilities and there's a lot of conditional probabilities and you're not quite sure how to get to the final answer of what they have, usually the tree diagram will help a bit there.